NASA already knew that Orion's heat shield had not behaved as it should, and even so, it put 4 people inside, not because it ignored the risk, but because it understood something more unsettling. The problem was not in a visible failure, but in a betrayal of physics that occurred during the return of Artemis I. During 6 minutes of plasma blackout, while Orion falls toward Earth at tens of thousands of kilometers per hour, no one can help the crew. No one can correct anything. And this time, unlike any routine flight, the real suspense was not in going to the moon. It was in returning with a shield that had already surprised its own engineers. At first glance, the return seems like a perfect choreography. Separation of the service module, orientation of the shield, atmospheric entry, blackout, parachutes, splashdown. But that clean sequence hides a brutal truth. Returning from the moon is not coming home. It is passing through an invisible wall of air at nearly 25,000 miles per hour, enduring temperatures close to 5,000 degrees Fahrenheit, and trusting that a layer of ablative material will destroy itself exactly as it was designed to do. And if that destruction occurs in the wrong way, the problem is not that the spacecraft heats up. The problem is that the heat gets trapped inside. That was precisely what NASA did not expect to find after Artemis I, and what forever changed the way Artemis II had to return to Earth. Orion was not returning with only 4 astronauts. It was returning with a huge question about the entire lunar architecture of the United States. If Artemis II failed on re-entry, not only 4 historic names would fall. Confidence in the vehicle that must carry human beings to lunar orbit, sustain them in deep space, and bring them back alive from speeds that no low Earth orbit mission experiences would fall. That is why this story matters. Because in space, the most beautiful moment seeing Earth grow in the window is usually attached to the most merciless. And because the crew knew that the most cinematic segment for the public was, in reality, the loneliest for them, the question was not whether it would look spectacular. The question was whether that shield, that last frontier between 4 lives and a hell of plasma, would respond as it should when no one could speak to it. It would not be the first time the world held its breath during a lunar return. On the 17th of April, 1970, Apollo 13 fell toward Earth's atmosphere after one of the most fragile missions in history. The spacecraft reached 24,689 miles per hour. The air around the module is ionized. The voice disappeared. Blackout. Several minutes, during which Earth did not know if the 3 men were still alive. When they emerged from the silence, the capsule deployed its parachutes and, in mission control, a celebration erupted that NASA described almost as pandemonium. That detail matters, because the terror of lunar return has never been measured only in engineering. It is measured in seconds without response, in the sound that does not arrive, in the delay that feels too long. But even before Apollo 13, the moon had already taught another, quieter lesson. In December 1968, the astronauts of Apollo 8 orbited another world and discovered that the real finding was not the moon, but Earth. Jim Lovell said, "The vast loneliness up here is awe-inspiring, and it makes you realize what you have back there on Earth." And Bill Anders summarized the paradox with an immortal phrase: "They went to explore the moon and ended up discovering Earth." That tension between wonder and vulnerability did not disappear over time. It only changed form. In Artemis II, half a century later, the beauty was still there. But beneath it pulsed a question that Apollo never had to answer in this way. What happens when the maneuver designed to make the return safer ends up creating an unexpected behavior in the heat shield? Here comes the twist of the story. For years, Orion was presented as a capsule that surpassed Apollo in a crucial point: its ability to perform skip entry, a bouncing re-entry, like a flat stone skipping over water. The idea was brilliant. Instead of plunging all at once into the atmosphere, the capsule touches the upper layers of air, slows down, comes out a bit, and then re-enters for the final descent. That reduces acceleration loads, spreads heating over 2 events, and allows much greater precision in targeting the splashdown location. In theory, it was an elegant evolution. More control, more safety, more flexibility to avoid bad weather and recover the crew quickly. But Artemis I revealed the opposite. NASA found more than 100 areas where the charred material of the shield had detached in unexpected ways. Not because the shield had failed catastrophically, worse, because it had functioned within a thermal environment that the models did not reproduce with sufficient fidelity. The gases generated inside the avco could not vent as expected. Pressure built up. Horizontal cracks appeared near the surface. Fragments of the material broke off. The very maneuver intended to soften the return had created a thermal window in which the material behaved differently. It was not a simple accident. It was a ruthless contradiction. The capsule's most advanced re-entry technology had produced the behavior NASA least anticipated. And there lies the detail that makes this story so human. If the problem had been a grotesque crack or an out-of-control temperature, the fear would be obvious. But the data from Artemis 1 showed something much harder to process. If there had been a crew on board, it would have been safe. The cabin remained at comfortable temperatures. Overall, thermal performance exceeded expectation. However, that did not reassure anyone immediately, because an agency that has learned the hard way from Apollo 1 to Columbia knows that surviving once is not the same as understanding why you survived. That is why the investigation was so long, so obsessive, and so uncomfortable. More than 100 tests, samples extracted from the shield, independent review. NASA did not just need to know if it could fly, it needed to know what risk it was asking its astronauts to accept. And that is a moral question before it is a technical one. The solution for Artemis 2 was almost poetic in its irony. Since the shield was already installed, NASA did not replace it. It changed the return. It shortened how long Orion could fly between the entry point and landing. And according to Orion program officials, it took the mission to an entry profile more similar to Apollo, more direct, less full skip, less time within the thermal range that had generated the unexpected phenomenon. In other words, to bring the future back home, NASA had to ask the past for help. But capsules do not feel fear. People do. And Artemis 2 did not carry mannequins or isolated biological sensors. It carried Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. 4 people forced to turn a vehicle still in a testing campaign into a temporary home hundreds of thousands of miles away. Wiseman said it with an almost childlike clarity. And for that very reason, devastating. Sending 4 humans 250,000 miles away is a Herculean effort, and only then were they beginning to understand the gravity of what they were doing. That phrase matters because it dismantles the fantasy of astronaut invulnerability. They do not go without thinking. They go thinking very well. They know what can happen, and they fly anyway. Christina Koch gave another form to the same vertigo. Before the great journey, she had said that this mission does not leave Earth, it chooses it. And afterward, during the flight, that idea took on a different weight. Because the farther a human being moves from their planet, the more intimate their relationship with it becomes. Victor Glover expressed it from a perspective that goes beyond flags or space program. From up there, humanity looks like a single thing, a single species, a single world. And there emerges the psychological layer of the return. After contemplating Earth as an oasis in the blackness, the moment of re-entry is not simply a procedure. It is the instant when that immense beauty compresses into pure material dependence. Everything they love is below. Everything depends on precise geometry, exact thermal loads, and an Avcoat shield doing its job in silence. Jeremy Hansen spoke of humility. Glover spoke of awe. Koch spoke of humanity. Wiseman spoke of the impossibility of processing certain images with normal words. And that emotional mosaic matters because long missions are not sustained only by discipline. They are sustained by meaning. The moon does not forgive inner emptiness. When communications cut out, when the body sinks into the sea under nearly 4 Gs, when the glow outside turns the windows into a boundary of fire, each astronaut returns to a very ancient question. Whom do I trust? The vehicle? The people who built it? The history that brought me here? Or that strange mixture of training and faith that turns the improbable into routine? The return of Artemis 2 was exactly that. A test of materials, yes, but also a test of human trust accumulated over decades. And NASA was not carrying a single concern either. The Inspector General had pointed out other risks in the Orion program: electrical distribution anomalies, problems in separation bolts, issues with batteries and life support systems. None of those topics is part of the heroic image the public usually remembers, but all are part of the real psychological climate of a mission. Because space fear rarely arrives as a single monster. It arrives as a collection of small technical uncertainties that must remain dormant at the same time. The crew of Artemis 2 was not returning only through plasma. They were returning through the institutional memory of an agency that knows space punishes, especially harshly those who confuse previous success with immunity. And then the moment comes, the 10th of April 2026. Orion separates its service module at 7:33 p.m. Eastern Time. Minutes later, it adjusts its orientation to present the heat shield to the atmosphere. At 7:53, the spacecraft touches the upper layers of air at 400,000 feet above Earth's surface, traveling at 35 times the speed of sound. Almost immediately, plasma envelops the capsule. Silence. 6 planned minutes of blackout. In the transmission on Earth, that is just a few tense moments. Inside the spacecraft, it is something else. Vibration, deceleration, invisible fire brushing against a structure on which 4 lives depend, and the total impossibility of speaking to anyone. There is no advice from Houston. There is no comfort, only procedure, breathing, muscle memory, and waiting. What is extraordinary is that the great twist of this story was not an explosion, nor a public failure, nor a moment of visible panic. It was something more sophisticated and, for that very reason, deeper. NASA had spent years preparing for a return in which the enemy was not absolute ignorance, but a known anomaly, an unexpected behavior that forced a redesign of the return trajectory, a risk that did not cancel the mission, but did make it morally heavy. And when communications were restored at 8 p.m., when at 23,400 feet the drogue parachutes deployed, when at 5,400 feet the 3 mains opened, when Orion touched the Pacific at 8:07 p.m., the relief did not come only because the crew was alive. It came because NASA had just demonstrated that it had learned something essential: to listen to physics before challenging it again. That is the true payoff of the story. NASA did not expect a theatrical crisis during the return of Artemis 2. What it did not expect, years earlier, was that its own re-entry innovation would reveal a new vulnerability, and that discovery changed everything. It changed the trajectory. It changed the internal conversation about risk. It changed the type of trust that had to exist between engineers and astronauts. In the end, Artemis 2 returned home not as a mission that ignored the warning, but as a mission that accepted living within it. And perhaps there lies the most honest definition of human progress. Not advancing when danger disappears, but advancing when you finally understand its shape. Because Artemis 2 was not only the return of human beings to the vicinity of the moon for the first time in more than half a century, it was the final exam of a promise that the Artemis program can learn, correct, and move forward without lying to itself. Apollo taught humanity how to arrive. Artemis is trying to teach it how to stay. And staying demands something more difficult than epic feat. It demands reliability. It demands repeating the impossible until it becomes habitable. It demands turning a historic journey into the first page of a lasting present. But if you want to understand what comes after this moment, after the splashdown, after the relief, after proving that Orion can bring humans back alive from deep space, then the next question is even more dangerous. What happens when that same architecture no longer only has to orbit the moon, but to dock, transfer crew, and land human beings at the lunar South Pole, where the light is oblique, the shadows are thermal traps, and an era no longer ends in the ocean, but nearly 400,000 kilometers from any rescue? That story begins with Artemis 3, and there, the real risk is only just beginning.